Here we are with the condensation polymerization. You know, condensation polymers are formed when two different monomers. This is most important thing. In addition polymers, we learned the similar monomers, similar unsaturated monomers were linking over there. Here you can see in condensation polymers, two different molecules, two different monomers with different functional groups. They will be bonding together, they will be joining together, and as they join together, they release another simple molecule as well along with the polymer. And this simple molecule, most of the time you will see water. So in contrast with the addition polymers, the condensation polymers form by the combination, by the bonding, by the joining, by the linking of two different monomers. And as the two different monomers link up together, they release, they eliminate a water molecule or some other simple molecule. That's how we define the word condensation polymers, and phenomenon is called condensation polymerization. It's again a reminder for you that addition polymerization, it forms the polymer molecule only, addition polymerization. But in condensation polymerization, we will be having two products, that is the polymer and the other simple molecule as well. So this is the main difference between addition polymerization and condensation polymerization, that in addition polymerization, we have only polymer as the product. And very important thing, in addition polymerization, you will see that the parent chain is having only carbon-carbon bonds. No other element will be there. In this parent chain, you won't find any nitrogen, in any oxygen, sulfur, phosphorus, no. Just the parent chain is made up of carbon atoms in the addition polymers. You can identify the addition polymers easily. But in condensation polymers, you will certainly find some other atoms as well, some other elements as well. Let's look into the more detail of the condensation polymerization. Here we are with a few examples of the condensation polymers. A frequently asked example in past papers, nylon. It is a polyamide. Poly means, you know, many. Poly stands for many, right? And about amide, I told you in the introduction that amide bond is this bond. This is the amide bond, or amide linkage, or amide functional group, whatever you call it. So a polyamide means this linkage you will see repeatedly, many times this linkage will be repeated. This bond will be repeated many times. That's why we call it as the polyamide. So nylon has amide linkage. That's why we call nylon as the polyamide. Dear students, you know very well that condensation polymers are formed by the joining, by the linking, by the bonding of two different monomers. Whenever we use the word two different monomers, it means both of these monomers contain different functional groups. So let's have a look at the monomers which are used to make nylon. Monomer number 1 is a carboxylic acid. Monomer number 2 is an amine or amine, whatever you pronounce. Now you can see this carboxylic acid has two functional groups of carboxylic acids on the terminals. That's why we call it as a dicarboxylic acid. Dicarboxylic acid means it contains two carboxylic acid functional groups on the terminals. And this box, which you can see, this box show the carbon hydrogen repeatedly so many times, right? So you must draw this box as it is, no issue at all. So the first monomer for the making of nylon is dicarboxylic acid. The second monomer is diamine or diamine, whatever you pronounce, because it is having two amine functional groups. Amine is a derivative of ammonia, remember? That's why its name is amine or amine, whatever you pronounce. Again, this box, you can look into this box. This box shows nothing but the CH2 groups repeatedly in between many times. You need to make this box as it is whenever we will be making the polymers. So first of all, the main thing about condensation polymers, that these polymers are formed by the joining of two different monomers. Two different monomers means they contain different functional groups. You can see here the two monomers for nylon, they are dicarboxylic acid and diamine, and you can see they both are having different functional groups. That's why we say they are different monomers. Let's join these monomers. I'm going to join them now. Please remember, whenever these two monomers will join, the carbon oxygen bond breaks down from here. Carbon oxygen bond breaks down from here. So the whole OH group, it is removed. OH is given out from both sides. It happens from both sides. So both OH groups will be given out, right? So I am going to remove this guy as well, right? So this OH group and this OH group both are lost. Okay. From this monomer, this hydrogen is given out from both sides. So now we are having two hydrogen atoms and two OH groups. And you know very well what they will be making together. H and OH, whenever they combine, they will be making nothing but the water molecule. So you can see that if we are writing N here, that N number of times it is repeated, so the water molecules will be 2N. You can write 2NH2O. Okay, now see how they are joining together. You can see the OH bond, the OH group is removed, so this bond is vacant on both terminals. This carbon bond is vacant on both terminals, right? This is vacant on both terminals. And one of the bond of the nitrogen is also vacant. So this nitrogen and this carbon will be making bond together. This is the bond between carbon and nitrogen. And you can see the linkage CONH, which I told you, this is known to be the amide linkage. So in nylon, we has amide bond, amide functional group or amide linkage. So leave, you don't need to put hydrogen over here, right? So you don't need to put OH over here. Just show these are the continuity bonds, right? Continuity bonds, and it will prolong for indefinite length. And if the N number of bonds are formed, 2N will be the water molecules, because two OH groups and two hydrogen atoms are lost. That's why it is 2NH2O. Point to remember, when the polyamide was made, the dicarboxylic acid will be losing OH group, as I told you. Please remember, this dicarboxylic acid, it always be losing the OH group from both sides. So both carbon atoms will be having a vacant bond now. Similarly, hydrogen will be lost from the both side of the diamine. So this nitrogen have a vacant bond as well on the both sides. So this carbon and this nitrogen, they will be making a single covalent bond here, which is shown in the diagram. and rest of the thing will be repeated as it is. And you must be able to identify this linkage, this bond. This is known to be the amide linkage. I hope you got it. One frequently asked question in past papers, they ask, name a natural polymer which contains the same linkage as in nylon, because nylon is a synthetic polymer, It's a man-made artificial polymer. So a natural macromolecule, a natural polymer which contains the same linkage as in nylon, it's protein. So protein is a natural polyamide, remember. It's a natural polyamide. And the difference between protein and nylon is that protein is biodegradable. It can be decomposed by bacteria with the help of enzymes, etc. And nylon is non-biodegradable. It does not decompose by bacteria or by enzymes. I hope you got it. Let's move towards some other examples of the condensation polymers, the man-made condensation polymers. Another important synthetic condensation polymer is terylene, which is a polyester. Poly means many. Ester, you know very well, this is the ester bond, dear students. I told you in the beginning of the video, this is supposed to be the ester bond, right? This guy is the ester bond. Fine. So polyester means this bond will be formed many times in this polymer. That's why we call it the polyester. So terylene is an artificial polyester, man-made polyester, synthetic polyester. So let's look into the monomers of terylene first of all. The first monomer is same as you learned in nylon. It's a dicarboxylic acid because it contains the two carboxylic acid functional groups. The second monomer in terylene is different from the nylon. It's a diol. You can think about the ol, where you learned about the ol. Yes, alcohols. In alcohols, we have suffix OL. You can see the alcoholic functional group, OH group, is bonded on the both ends of the carbon. So it is having two alcohol functional groups, two hydroxyl groups, two alcohol functional groups. That's why the name of this monomer is diol. Now, in order to make the terylene, in order to make this polyester, in the similar way as we learned that these two OH groups will be removed. You can see here, the OH groups are removed from both carboxylic acid parts, from both ends. Similarly, this hydrogen and this hydrogen will be removed from the diol. And you can see now oxygen is having a vacant bond, so as the carbon on the both sides. So the carbon and oxygen, they will be making a bond together. This is the bond formed between carbon and oxygen. And this unit is repeated as it is. And I am writing here n number of times it is repeated. So the water molecules again will be twice of the N to NH2O. You can again see in this polymerization, there are two products. The one is organic product, which is the polymer, which is the condensation polymer, and the other is inorganic molecule, that is the water molecule, which is an example of a simple molecule. Again, remember when the polyester, because this, now identify this linkage. We learned about this linkage in the beginning. This is known to be the ester linkage. Yes, rightly identified. That's nice. It is known to be the ester linkage or ester bond or ester functional group, we call it. So these are the two different linkages you must remember, amide linkage and ester. Amide linkage is found in nylon and in proteins. Nylon is synthetic polymer, synthetic condensation polymer. Protein is a natural polymer. Similarly, you must keep this linkage in mind. This is ester linkage, ester bond. So pterylene is an artificial polyester, right? Pterylene is an artificial polyester. And again, examiner asks a question, name a natural polymer, name a natural macromolecule which contains the same linkage as in pterylene. So that natural macromolecule, they are fats. So fats are natural polyesters. Fats are natural polyesters, remember. I hope you got it. Again, the difference between fat and pterylene, apart from the fact that they both are polyesters, they both have the same linkage. Apart from this similarity, there is a difference between fats and pterylene. Again, because pterylene is a man-made, it is non-biodegradable. But fats are biodegradable. They are decomposed by the bacteria, by the enzymes, while pterylene is non-biodegradable. It is not decomposed by enzymes or by bacteria. I hope you got it. And let's move through some practice questions from the condensation polymers as well. Exam style question. Pterylene is a condensation polymer. The structure of pterylene is shown below. Now, you know very well, you just learned that pterylene is a polyester. It has many ester linkages. You can easily identify the ester bonds in between the chain. What is the name of the linkage shown in the structure? Very simple. You can just write the ester linkage. Very simple. What we learned, we are using our knowledge and understanding now. We are applying our knowledge and understanding now to solve the past paper questions. So this is the simple answer for part 1. The part 2 says, name a natural macromolecule that contains the same linkage as pterylene. You just learned that a natural macromolecule which contains the same ester linkage that are supposed to be the fats. And now I'm going to assign you a home activity to do yourself, please. You must draw the structure of a polyamide such as nylon. You should not forget that this is the amide linkage which is found in nylon. You can easily make the structure of nylon we just learned. So this is the end of this session upon polymers, which, dear students, you requested to me, and I honored your request. Please send me the feedbacks about it and keep on focusing on your studies. Keep on focusing on revision for your examinations. Best of luck to all of you. Good night. Allah Hafiz.